Of course, nothing goes right from the first time. When we started to build our prototype, the first try was we built it with pipes, but it wasn't stable enough. Therefore, when we adjusted the motor, the pipes broke down and it wasn't balanced. So therefore, we added some wooden frames underneath the pipes so that it can be stable enough to work while the motors are working. The second failure that happened was that when we adjusted two motors, one was moving very slow and the other one was extremely fast. Therefore, we had to adjust both motors to have the same output voltage. So, from a professional point of view, he helped us and said to take a transmitter and link both motors to that transmitter so that the output voltage will be the same and the speed will be slow so that the thread could wind up the pipe. When we adjusted both motors, we fixed them with some steel parts, but the problem is, for the second motor, it wasn't fixed properly. It used to fall. Therefore, we needed an alternative to fix the motor and other parts as well, like the resin pool, the mandrel, and the thread. Therefore, a guy recommended to use acrylic. So when we went to him, he took the specifications of the motor, of the thread, of the resin pool, and he designed the acrylic for us so that we can place the motor perfectly, and the mandrel as well, the resin pool, and the thread. So the acrylic was the best alternative we got to stabilize our prototype. Hello everyone, as you can see this is our prototype fabrication of fiber reinforced pipes. So to start off, we applied resin on the pool and on the pipe, allowing the thread to stick on it. Then the thread will pass through the resin pool, allowing it to wind up the pipe. How did we do that? By applying a motor here and here. The first motor will create a rotational movement, but due to the mandrel connected to the motor and a nut placed underneath the resin pool will move to the left and to the right. The second motor will only create a rotational movement, allowing the thread to wind up the pipe. How did we adjust both motors to have the same output voltage? By connecting them to a transmitter and adjusting the voltage to 12 so that they can have the same speed or the same output, so nothing can go wrong in the procedure. Okay, we connected both motors to two switches. This switch is for that motor and the second switch is for that one. When I click this one, it will create a rotational movement. The pipe is moving rotationally. Click this one up, the resin pool will move to the left, because this motor is creating a rotational movement and the nut is placed underneath, so when it moves like that, the resin pool will move to the left. And when I click when I click the switch down, it will make the resin pool move to the right. So as you can see, this is the movement applied and the thread is moving the resin pool, allowing it to wind up here on the pipe so that it can be fixed. Thank you all for watching. I hope you enjoyed.